Let's do the first quality of service lab. This will be a basic lab. We are not going to use nbar. We are not going to use ABC. We are going to use basic access control lists for classification. Also notice that we are using CSRs. CSRs by default are only able to transmit 1 megabit per second. This is the licensing for free to use CSRs. If you need more bandwidth, you can always buy a license from Cisco. So this is an advantage because if these routers can only manage 1 megabit per second, we can easily saturate the links in order to show how quality of service can be of advantage. Now, for this lab, we are going to transmit video. From Ubuntu 1, we are going to send video to Ubuntu 2. I have already set that up. So, for instance, we have this. Ubuntu 1 is sending video through VLC, and Ubuntu 2 is receiving this video in a loop. After the video finishes being received, it has a small pause, and then it loops again. So far so good. This traffic is being charted using Netflow. So I have a separate device that is capturing this traffic. So for instance, from CSR1 at gigabit 1, we are receiving about 200 kilobits per second. That is what this video transmission is using. So we can validate that going into the router. For instance, if we go into CSR1, we can check that if we issue show interface gigabit 1, we can see that the traffic rate is around 200 kilobits per second. Remember always to go into your interfaces and issue this command, load interval 30. That is the minimum amount of seconds, so you can get appropriate measures of real-time statistics on your router. So Cisco will calculate this rate, and it matches what we are receiving at our Netflow server. So in this lab, we are using only these two CSR routers being connected back to back. This is the connection to the Netflow server, so you can ignore this by now. So first of all, we have to observe UDP traffic that corresponds to video. So if we capture here traffic, we will be able to see the UDP traffic. Notice that it is using random UDP ports. So given we are not using nbar, we are going to use access control lists. We need a way to start figuring out how to classify this traffic. So if we observe this traffic, it is using UDP with random ports and then real-time transport protocol within UDP. Notice that the traffic is not being marked. So if we go for the IP header, we have this set to 0. The DSCP is set to 0. And we can observe that the video is being transmitted correctly. Now we are going to break this. We are going to saturate this link between CSR1 and CSR2. This link it's going to get saturated. So we are going to go to the point number 2, start many FTP sessions. So the video stopped working, and we are going to observe the traffic. So we are going to go here, and here I have some FTP sessions that we are going to fire up. So I'm going to pause the video. I'm going to set up many FTP sessions and to see how the traffic is going to start getting saturated on the WAN link. Okay, it is ready to start sending traffic, so we're going to start one FTP session here, and we are going to see how the traffic starts to grow from 200 kilobits per second as the FTP starts to consume the bandwidth in the WAN link. So eventually these FTP sessions will consume all the bandwidth. Let's fire up the other sessions. So I have 4 FTP sessions running simultaneously, and then we are going to see how we reach 1 megabit per second. We can see that in our we will be able to see this in our Netflow server. So see how this is increasing slowly, and then when this happens, the video is going to start to become unresponsive. So the video is already stalled. There is this orange marker that indicates that we are not receiving video traffic at all. So if we examine the WAN link, we will be able to see that it is almost consumed by FTP traffic, which is TCP traffic that is not marked. We can go here and see that it is not marked, no value at DSCP. And then we have FTP data. Notice that we are also using random TCP ports. Even we are not using the regular FTP transmission, we are using passive mode. So in these passive mode scenarios, random ports are used in order to move the traffic. Now, let's go to action item number 3. Use quality of service to limit TCP traffic to 500 kilobits per second. Make sure end-to-end quality of service policies are applied using per hop behavior, and we also have to guarantee priority queuing for video. So we need to configure quality of service in this router at every single interface, and in this router CSR2 at every single interface. So we will need to set up an input policy map here at gigabit 1, an output policy map here, and the same applies for every single interface. For gigabit 2, we'll have to set up an input policy map, an output policy map. For gigabit 2 at CSR2, we'll have to do the same, and so on. Notice that for the input policy map at the LAN interface at each router, we'll have to do classification and marking. The other policy maps will only do policing, and at some points they will have to do priority queuing. Notice that, for instance, this input will only do policing, and this input will only do policing because once the traffic is marked and you're going to do policing, some devices cannot handle priority queuing on the ingress. Some devices can only handle priority queuing on the egress. So output with priority queuing, output with priority queuing, output with priority queuing, and output for priority queuing. So in summary, we have this impact here, and we are going to resolve it with we're going to solve that with quality of service. So let's go to CSR1 and let's do this policy map that is going to do classification and marking. So first of all, we will need our access control list. So we are going to create an access control list for UDP traffic that is going to extended UDP, and we are going to permit all UDP traffic that goes from host Ubuntu 1 to Ubuntu 2. And then we are going to create an access class map, class map UDP that is going to match this access list. Now, this is the part of configuration that is going to classify incoming traffic, and this is going to classify UDP traffic that belongs to the video traffic. Now, let's create a classification configuration for the TCP traffic that corresponds to the FTP traffic. So, IP access list extended TCP, permit all the TCP traffic going from host to host. And then the corresponding class map for TCP traffic is going to match access so far we have this access list, TCP and UDP, and these class maps. This class map will match UDP traffic, and this class map will match TCP traffic. Now we are going to create the policy map for classification and marking. So it will be policy map, LAN input. So for class UDP, we are going to mark now. So DSCCP AF41. We usually use AF41 for video. And then for class TCP, we are going to mark that as EF21, for instance. So that will be all for our policy map for input. So let's see how it's our policy map. Oh, notice that we are reaching 1 megabit per second, and the CSR is sending us a log saying that the average throughput has approached to the licensed bandwidth of 1 megabit per second. So this means our FTPs are working. This is what we wanted. We are saturating the WAN link. So let's see our policy map. This is our classification and marking policy map. So let's attach that to the interface gigabit 1, which is my LAN interface. Service policy, input, LAN input. And once I do that, I can gather statistics. So I can issue show policy map, interface, gigabit 1, and we start to see statistics. All the TCP traffic is getting marked with AF21. And notice that we get at class default. Every time you create a policy map, you create a class default by default. You don't have to type it in. It gets created by default. You can modify it if you want. And so you can gather statistics. Eventually we will see UDP traffic here because we are still sending video from Ubuntu 1. We are sending these packets here. So at CSR, we should see some traffic here. We still are not seeing it, but eventually we will see it. We can check on our Netflow server, and we can see that we are saturating the link. We are sending up to 1 megabit per second in traffic due to our FTP sessions. So let's see our access list. UDP, all the UDP coming from this host to this host. So it is gonna take a while to show up here. Notice that we are seeing almost 1 gigabit per second in traffic coming from TCP. Okay, so now let's continue and configure the policy map for the WAN link. So in order to do that, we are going to do classification and policing. So in order to do classification for the egress, we are going to create some class maps. For instance, class map egress video. So we are going to match DSCCP AF41, and then we are going to create a class map for egress TCP. We're going to match DSCCP AF21. We already marked the traffic on the ingress, so we will be able to classify it on the egress. So now let's create the policy map. Policy map WAN output, and then for class egress video, we're going to use priority level 2. 2 is for video, and then we are going to guarantee 500 kilobit per seconds for video, and then for class egress TCP, we are going to police it. We are going to police with 500 kilobit per seconds, and then for the exceed action, we are going to drop that. So that is my policy map WAN output. We're going to see that, and let's attach this policy map to the WAN interface. So my WAN interface is gigabit 2, and I'm going to issue service policy output WAN output. So I can now gather statistics. So if I issue show policy map interface gigabit 2, which is my WAN link, I can already see that for video, I am offering now a rate of 9 kilobit per second. This should go up as time goes by. And then for the TCP that belongs to the FTP traffic, this is the traffic. We are already dropping some packets. Let's see gigabit 1. Notice that we have now statistics on the input policy map for the gigabit Ethernet 1. We are marking all this traffic. So this traffic is getting marked with AF41, and this traffic is marked with AF21 at the ingress. And at the egress, at the WAN link, I am letting all that traffic pass. I am not dropping that video traffic, but the TCP traffic, I am receiving this that goes beyond the limit, which is 500 kilobit per second. I am receiving more than 500 kilobit per second, so I am dropping this amount of packets. So this is the way that you can see statistics for your quality of service policies. Now, at this point, we have solved the problem. The video is being able to be seen because we are limiting the TCP traffic that is the FTP traffic. And if we examine this traffic, we can see that the FTP traffic is being marked with AF21. AF21. And the UDP traffic is being marked with AF41. Now we have to continue configuring all the other policies that we need. We need to set up 1, 2, 3, 4, 5, 6, 7, 8 policies. We only have configured 2 policies so far. So in order to guarantee per hop behavior end-to-end, we will have to go and configure all other quality of service policies. Even though that we have solved the problem with these 2 policies, we have to comply with Cisco best practices and complete our configuration. So let's configure now the policy map for the output for the LAN interface. Because if we do this, should run interface gigabit 1, we only are managing the input. We have to manage the output for the LAN interface. So we need another policy map. So let's create that policy map LAN output for we're going to have to create a couple of class maps, but if I'm not mistaken, I think we have we have this and we have this. We're going to use that because that is used for the egress. So let's create a policy map LAN output. We are going to use class egress video, and we are going to use Prioity queue level 2 because level 2 is for video, and we are going to guarantee 500 kilobit per second. And then for class egress TCP, we are going to police to 500Ks, and then we are going to drop the exceeding traffic. That will be my policy map for the LAN output. So let's go to the LAN interface and attach it. Service policy output LAN output. So this policy map is not doing marking, it is doing policing because it is the traffic that is going to be delivered from the router into the local area network. You usually do classification and marking for the traffic that arrives from the local area network to the router. So we have these 2 policy maps. So we are going to do classification and marking here, and we are going to do queuing and priority queuing and policing with the egress policy map. So you can always show your statistics with show policy map interface gigabit 1. And here we will see the input policy map and the classification and market statistics, and the output policy map with the queuing and policing statistics. So we have two policies in the LAN interface, and we need still one policy in the wide area network interface. So let's create that. Policy map one input. We're going to use the class Egress. This the name doesn't make sense because we are using the Egress video for an input class, and that happens because we are talking about marked traffic. If we wanted to have more easier to read configuration, we could create another class map, marked video, and match the SCCP EF41, then class map marked TCP traffic, and we will do match the SCCP AF21. Then, so I just created another couple of class maps, so the names make sense. So let's create the policy map one input for the class marked video that we are going to receive. And probably we are not going to do anything, but for the marked TCP, we are going to police at 500 kilobit per second and exceed action drop. We are not going to do priority queuing here because in this particular hardware we cannot use Ingress priority queuing. In some platforms, for instance, the Catalyst 6500 series, you can do priority queuing in the Ingress. But in this case, the CSR 1000 cannot do priority queuing in the Ingress, so that is why I'm not doing that here. So my policy map will be this. For the Ingress part at the wide area interface, show policy map one input. So I'm going to attach that to my wide area interface. That will be gigabit 2, and then will be service policy input one input. So I have my two policies at the wide area network interface and my two policies at my LAN local area network interface. So that will be all for CSR1. I will need to do the same for CSR2. I don't see the point of showing that in the video because it will be exactly the same that we did here. So let's show our policy maps just as a summary. Show policy maps. This is the LAN input where we are going to do classification and marking. The LAN output when we are doing queuing, priority queuing, and policing. Now for the wide area network, we are going to do for the input, we are going to do only policing, classification and policing. We are not doing classification and priority queuing because this hardware cannot support that in the input. And for the wide area network in the output, we are doing classification and priority queuing and classification and policing. Let's see how the Netflow servers show this traffic. So for instance, if we go to CSR2, in the wide area network, after this is the traffic that was being received before executing quality of service. The line was saturated. This is the traffic that can be seen after applying quality of service. We are regulating the traffic. Remember that FTP is being polished to 500 kilobit per second, and our video was around 200 kilobit per second in bandwidth. So we have around 700 kilobit per second after applying quality of service. That's it.